This is the rest of our lessons on mechanics, kinematics. So we didn't finish some of the questions, and there probably will be maybe 2 more videos on kinematics. So yeah, in total we should spend about 3-4 weeks on kinematics before we move to dynamics. And here I have pictures for you of the car, and this car is the first one, A, is moving at a constant speed, so there's no acceleration. So each time interval it covers the same distance. The second car starts with slower velocity and then accelerates, so it has positive acceleration. So if it has positive velocity and you add acceleration each second, your velocity is going to increase. So the B version has positive velocity, positive acceleration. But the C part, you see the car had large velocity, but next second, so there's a big velocity at first, but next second it's less velocity, and even less velocity, and even less velocity, and it covers less and less distance each second. So that means it's losing velocity. Because it's losing velocity, its acceleration is negative. So you have positive velocity, and each second you add negative acceleration, you get a smaller velocity. Let's look at some questions that I could not fit in the previous video, but I want to still solve it for you for your practices. So read the question, write everything that is given before we start solving. Try to solve it yourself at first, and then watch me solving it. So I wrote down everything that is given. They ask you to find the distance traveled, and I will also find acceleration in this question. Initial velocity of the dog is 6 meters per second. Final velocity is 0 because the dog stops. And then they tell you that it takes 4 seconds for the dog to stop. And I need to find the acceleration and the distance. So I wrote both formulas for acceleration and the distance. And now I'm going to plug in. So at first I'm going to find the distance. The distance is average velocity. Average means, so if I have average velocity, that means initial plus the final divided by 2 times the time. So that gives me 12 meters. And then the acceleration is change of the velocity. And change of the velocity again means final minus initial. So final minus initial divided by the time it takes. So that gives us 1.5 meters per second squared, and it is negative because it is decelerating, like an example with the car that we just looked. It had the dog had positive velocity, but each second it gets less and less velocity left and less distance traveled each second. So because acceleration is in the opposite direction of the velocity. This is an interesting question, and I'm going to do more questions related to the free fall, but this is the first example of the free fall. And in this case, they say the ball is thrown upward with initial velocity of 30 meters per second, and it decelerates at 10 meters per second squared due to the gravity. How long will it take for it to stop, and then how far into the air will it rise? So again, let's write everything that is given, write down the formulas, pause it, try to solve it, and then let's do it together after you are done so you can check your answers. So I have initial velocity, I have acceleration or deceleration, and I have the final velocity 0. Because acceleration is given, I can use acceleration formula to find the time. So if I solve for the time, this formula, time is equal to change of the velocity over the acceleration. Final velocity is 0. Initial velocity is 30. And acceleration is negative 10 because it's deceleration. So it's going to take 3 seconds for the ball to reach its highest point. How far into the air will it go? So how high is the distance, right? Because it's the distance, I'm going to call it height. It is the average velocity times the time. Average velocity means initial plus the final. divide by 2, and I just found what time is, 3 seconds. So the height is 15 times 3 and gives me 45 meters. Also, here is the first time you see this acceleration. This acceleration is called acceleration due to gravity. This acceleration is called acceleration due to gravity, and it has a letter G. So sometimes you will see G instead of acceleration. Don't call it gravity. It's not gravity. It's acceleration due to gravity. Sometimes when you say gravity, people will think that it is force of gravity, but this is acceleration due to gravity. And it is 9.8 meters per second squared. Acceleration due to gravity on Earth is 9.8 meters per second squared, but on different planets it's a different number. So we're gonna round it every time we see it to 10 meters per second squared. Here's another question. In this case, you have initial velocity of 22 meters per second. It will eventually stop, so the final velocity is going to be 0 meters per second. The acceleration, again, acceleration due to gravity is negative 10 meters per second squared. And the question is, how high into the air will it go? And how long does it take to reach the highest point? So if I'm looking for the time, I can use acceleration formula, and it is acceleration. So your acceleration formula says it is the change of the velocity over the time. So time is equal to change of the velocity over the acceleration. The final velocity minus initial velocity divided by by acceleration, which is negative 10. So that gives me 2.2 seconds to reach the top. So if the ball is thrown upward and it reaches the top and the time it falls down, so the time it takes to get to the top is 2.2 seconds, and the time it takes to fall to the bottom is 2.2 seconds. So the ball is actually going to stay in the air for 4.4 seconds. But the height it travels to the top is the same as distance, how far into the air, so that is the distance. I can use average velocity times the time formula. So the height is equal to average, which is initial, plus the final, divided by 2, and the time we took 2.2 seconds. We figure out it's going to be 2.2 seconds. So looks like that's going to be 22 meters. Here's another good example to look at. An object accelerates at 3 meters per second squared for 7 seconds. And if the object was originally moving at 2 meters per second, so initial velocity is given. Initial velocity is 2 meters per second. Acceleration is 3 meters per second squared, and the time is 7 seconds. And here this is what we have to do. Find the final velocity in 7 seconds. So the final velocity is equal to initial velocity plus the acceleration times the time. Initial velocity is 2, acceleration is 3, and the time is 7 seconds. So that gives me 23 meters per second. What distance did the object travel over these 7 seconds? So if I need to find the distance, I need the distance formula, which is average velocity times the time. Average means initial plus the final, divided by 2, and times the time. Now I'm going to plug in my numbers for the distance. So initial velocity is 2. Final, I just found out that is 23. Divided by 2 times the time, which is 7. So I have 25 divided by 2 gives me 12.5 times 7 gives me 87.5 meters. And what distance did the object travel over the seconds that we found out? What distance did the object travel over the last second? Okay, then I'll have to do the graph. So I have 7 seconds. 1, 2, 3, 4, 5, 6, 7. And I start with 2 meters per second. Then acceleration is 3. So in a second, I have 5 meters per second. So these are my meters per second. 5 meters per second, and then I have 8 meters per second, and then I have 11 meters per second, and then 14 meters per second, 17 meters per second, 20 meters per second, and 23 meters per second. So I have 23 meters per second in 7 seconds. And I need to find the distance traveled over the last second. So over the last second, I need the distance formula. The distance is, again, average velocity times the time, but it's the average velocity between these 2 points. So I have 20 plus 23 divided by 2, and it's over 1 last second. So the distance traveled over the last second is equal to 21.5 meters. And then the distance an object traveled over the last 2 seconds. So now I need the distance traveled over the last 2 seconds. So I'm looking for this distance. And again, the distance is equal to average velocity. And I'm looking at 17 and 23 for these 2 seconds. So average 17 plus 23 divided by 2 over the last 2 seconds. So that's 2 seconds for the time. Average velocity times the time. 2 and 2 can be cancelled, and looks like it's going to be 40 meters. So over the last 2 seconds, an object traveled 40 meters. Here's one more question. A ball is thrown into the air at 70 meters per second free fall. So that means it has acceleration due to gravity downward at 10 meters per second squared. So if I assume that my up velocity is positive 70 meters per second, so that is initial velocity, by the time the ball reaches the top, it has the velocity of 0 meters per second. So it loses the velocity because there is downward acceleration, negative acceleration due to gravity, negative 10 meters per second. And then by the time it reaches back to the ground, it will have the same 70 meters per second, but in the opposite direction. So here are the questions. What is the velocity of the ball on the top before it starts to fall down? So the answer is 0 meters per second, because it stops for a fraction of a second before it turns around and starts falling down. What is the acceleration of the ball? Acceleration is negative 10 meters per second squared. That's acceleration due to gravity. How far into the air will the ball rise? So if I want to know how far into the air the ball will rise, I need the distance formula. So that is average velocity times the time. Average velocity. So initial velocity is 70. Final is 0. And divide by 2 times the time. I don't know the time yet. I haven't figured out the time. So let me find the time first before I can plug it in. So to find the time, I'm going to use acceleration formula. Acceleration is equal to change of the velocity over the time. So the time is equal to change of the velocity over the acceleration. In our case, acceleration is due to gravity. So the time is equal to the final velocity is 0. Change means the final minus initial. So final minus initial, 70, divided by acceleration, negative 10. So that's going to be 7 seconds. I think they will ask you this question, how long will it take for the ball to reach the highest point? So here is going to be 7 seconds. And then back to the distance or the height, I have average velocity is 35, and time times 7 gives me 245 meters up. How long did the ball stay in the air? So it takes 7 seconds to get to the top, and it's going to take 7 seconds to fall down. So it's going to be 14 seconds total. And I could also ask, what's the total distance the ball travels from the top to the bottom? So it goes 245 meters up, and it's going to go 245 meters down. So together will give me 490 meters. This question is not a difficult question. I just think they ask it differently, not the way you used to. So I'm going to just look at this question. A bus is moving at, and I have initial velocity of 12 meters per second, begins to slow down at the rate of 3 meters per second each second. So what does that mean? 3 meters per second each second. I think that's acceleration, and it's negative because it slows down. 3 meters per second each second, that means squared. How far does it go before it stops, and how long does it take before it stops? So I know final velocity is 0 because it stops. So because I have acceleration, again, I can use acceleration formula, which is the change of the velocity over the time. From here, I can find the time. So the time is change of the velocity over the acceleration. Final velocity minus initial velocity divided by the acceleration gives me 4 seconds. So that is how long it takes before it stops. And then the distance it traveled before it stops, average velocity times the time. And again, your change of the velocity is the final minus initial, but your average velocity is initial plus the final divided by 2 times the time. So the average is initial plus the final. So your initial is 12, final is 0 divided by 2 times the time. So that gives me 24 meters. So here's one more example. A car traveling at 16 meters per second when the driver is traveling for 16 meters per second when the driver notices an accident ahead of him. If it takes him 1 second before he slams the brakes and starts to decelerate at 4 meters per second squared. How long will it take for the car to stop since the driver sees the accident? And what distance did it travel before it stops? So here is the car, and it's traveling at 16 meters per second. So initial velocity is 16 meters per second. It takes 1 second before he reacts. So that means right here, there is still 16 meters per second velocity. And then he starts to decelerate at 4 meters per second squared. So I'm going to write the deceleration is negative 4 meters per second squared. And eventually he stops. So here is 0 meters per second. I do not know how long it will take for him to drive where he was decelerating, but I can find the time. Time is the change of the velocity over the acceleration. So 0 minus 16 divided by negative 4 gives me 4 seconds. So here it's going to take him 4 seconds to stop. And I can find this distance because here he was traveling at the constant speed. The speed wasn't changing. So you have the distance here traveled, average velocity. You have 16 initial, you have 16 final, divided by 2 times 1 second. And sometimes when they say average velocity and your velocity is constant, you just can write 16 times 1 and gives you 16 meters. And then for the second part, for this one, he is decelerating, so the velocity does change. So here you have average velocity, final plus initial, divided by 2, that's average, times the time, 4 seconds. So the distance here is 32 meters. The question is, what is the distance he traveled before he stopped since the moment that he saw an accident? So the total distance he traveled is 16 plus 32. He traveled 48 meters since the moment he saw the accident to the moment he stopped. And the time it took him 1 second for the first moment before he reacted, and then 4 seconds afterwards. So that is 5 seconds. Here's another good example. Luis is standing on the top of the cliff and he throws a ball straight upward, and after 1 second it reaches its maximum velocity. So it takes 1 second to reach its maximum velocity. and then it takes 3 seconds to fall down. So 3 seconds to fall down. So I know it's a free fall because the ball is flying in the air without any restrictions, just we assume that there is no air resistance, just the force of gravity acting on it. So there is acceleration due to gravity or deceleration due to gravity. That is negative 10 meters per second squared. And I know the time it's going to take 1 second to stop. And I know the velocity all the way on the top, the final velocity on the top is going to be 0. So the final velocity on the top is 0 meters per second. And I didn't know initial velocity. So I'm going to use acceleration formula. So the acceleration is change of the velocity over the time, because I have initial velocity. I don't have initial velocity. I have the final velocity, acceleration, and the time. So this is the final velocity minus initial velocity divided by time. So if I times both sides by t, I have a times t is equal to the final velocity minus initial velocity. The final velocity is 0 and acceleration is negative 10. So I have negative 10 times 1 second is equal to final velocity 0, and I'm looking for initial velocity. So the initial velocity is equal to 10 meters per second. And here's a little trick that you should know. If you throw something upward with some initial velocity and it stops in 1 second, each second acceleration due to gravity is negative 10 meters per second squared. Each second it loses 10 meters per second each second. So that's what acceleration due to gravity means. You lose 10 meters per second each second. If it stopped in 1 second, that means your initial velocity was 10 meters per second. What if it stopped in 2 seconds? Then the initial velocity was 20 meters per second. What if it stopped in 3 seconds? Then the initial velocity was 30 meters per second. Because if you have 30, in 1 second you only have 20, in another second you only have 10, in another second you lose the last 10, in 3 seconds you stop. So this is a good, interesting thing to know when you want to calculate things faster. Also, if I am at the top of the cliff and I drop something down, let's say initial velocity is 0 meters per second, then in 1 second it's going to have 10 meters per second because acceleration due to gravity is 10. In 2 seconds it's going to be 20 meters per second. In 3 seconds it's going to be 30 meters per second, and so on. Okay, now I'm going to calculate what distance did the ball travel to its highest point from where Luis is standing. So the distance, the height, is equal to average velocity times the time. His initial velocity was 10, so when he's throwing the ball upward, his initial velocity is 10, and the final velocity is 0. So his average velocity is 5, 0 plus 10 gives me 10 divided by 2, average, times the time, 1 second. So the ball is going to reach its maximum height at 5 meters from where Luis is standing. So I know that this part right here is 5 meters, and it took 1 second. And the initial velocity was 10 meters per second, and the final was 0 meters per second. Now, from the height, from all above the height from there, it's going to take 3 seconds. So from all the way over here to the bottom to the ground, it's going to take 3 seconds. That's what they were saying in the problem, right? So from all the way from the top, by the time it reaches the bottom, its final velocity is going to be initial velocity. Initial is 0, right? It's initial from that height because the ball stopped. So now it has initial velocity is 0. Plus acceleration times the time, and they say 3 seconds. So that is 30 meters per second. So when it hits the ground, it has 30 meters per second velocity. Or we can say in 1 second it would be 10, in 2 seconds it would be 20, and in 3 seconds it would be 30. And they say it reaches the ground in 3 seconds. So I can calculate this height, the total height, from how high the ball was compared to the ground. So Luis is standing somewhere here. The ball was flying like this and then falls down all the way to the ground. It took 1 second here, it took 3 seconds here, and we said this velocity is 30 meters per second. And we calculated that the velocity that he threw it upward was 10 meters per second. And the final, the top velocity here is 0 meters per second. So now I'm going to calculate the total height, this height. So this height is equal to average velocity times the time. So I'm starting from 0, and the final is 30. So average is 15, and the time to hit the ground is 3 seconds, so that is 3. So this is 45 meters, and this is what I got. So here is Luis. The ball goes here and then falls down on the ground. I calculated that this height is 5 meters, and I calculated that this height is 45 meters. Then Luis is 40 meters above the ground. Let's look at another question very similar to the one that we just did. So here is the cliff, and Luis is throwing the ball upward. It will go all the way to the top, turn around, and fall down. It doesn't mean it will move in this trajectory, but I'm just going to write it this way. And it reaches its highest maximum height in 3 seconds. So this part takes 3 seconds. I'm going to call this height H. And then it falls on the ground in 4 seconds. So this takes 4 seconds, and I'm going to call this height H. And I'm looking how high above the ground is Luis. So if it reaches its highest point in 3 seconds, then initial velocity must be 30 meters per second. Because each second you lose the velocity. Each second you lose 10 meters per second. So I also could use the formula. The acceleration is equal to change of the velocity over the time. The acceleration is -10. Final velocity all the way on the top is going to be 0 meters per second minus initial velocity we're looking for, and the time they said is 3 seconds. So I see that initial velocity is 30 meters per second. Now I can calculate the height. So I'm going to make this in yellow as well. So I'm going to calculate this height. The height is average velocity times the time. Initial is 30. Final on the top is 0. Divided by 2 took 3 seconds. So this height is 45 meters. Then I'm going to look at the second part, this one. It starts at 0 meters per second, and in 4 seconds, the final velocity is going to be 40 meters per second, because each second you add 10 meters per second. So you start with 0, and then in 1 second it's 10, in 2 seconds it's 20, 3 seconds 30, 4 seconds 40. But I'm going to use the formula. It's initial velocity plus the acceleration times the time. So the final velocity is equal to initial plus acceleration times 4 seconds, gives me 40 meters per second. So now I'm going to calculate this height and this height. And this height is equal to average velocity times the time. So initial 0, final is 40, that gives me 20. Time is 4 seconds, so this height is 80 meters. And here's the last part. If this is 80 meters and this is 45 meters, then Luis is 35 meters above the ground. And that's going to be it for this question. And the next one is going to have more free fall kinematics videos, and might be the last one. Maybe not, we'll see. So I will see you in the next video.